This is demonstration number 11 from the aviation textbook Advanced Airmanship, Book 1, Precision Flying. This is the third demonstration of precision transitions to new flight paths and airspeeds. Precision transitions have 4 pitch transition rules, a general pitch transition rule, and 3 basic pitch transition rules. The general pitch transition rule is determine exact pitch attitudes and power settings for all normal flight maneuvers. This demonstration illustrates Rule 2, which is called the Changing Airspeed Rule. It states, when changing airspeed only while maintaining the same flight path, change the power setting first. Then coordinate pitch attitude changes with airspeed changes to maintain a constant flight path. This demonstration shows how the rule is applied to the transition from one airspeed to another while maintaining a constant altitude. An airspeed increase is shown first, followed by an airspeed decrease. The data plot view will be shown first, followed by the same transitions shown in the flight deck view. On this plot, we are initially at 15,000 feet and 250 knots, which requires a pitch attitude of 2.1 degrees and EPR setting of 1.09. To change speed, we will first increase the EPR to 1.30 and also increase the plotting speed. Note that as the airspeed is increasing, the pitch attitude must be decreased along with the airspeed change. Slightly before reaching 340 knots, we will reduce the EPR to its final value of 1.12 to maintain the airspeed constant at 340 knots. Next, we will do an airspeed reduction. In order to decelerate to 300 knots, we will first set the EPR to 1.05. And as the airspeed is reduced, we must gradually increase the pitch attitude in order to maintain the altitude constant. Slightly before reaching 300 knots, we will have to set the final EPR setting of 1.11 in order to maintain the airspeed constant at 300 knots. Lift must remain approximately constant for altitude to remain unchanged. The lift depends on airspeed and angle of attack. To change airspeed, set a new thrust value. Then coordinate pitch attitude changes with airspeed changes to maintain a constant lift and altitude. Coordinating pitch with power will result in an unwanted change in altitude. Overpowering or underpowering to change speed and reset the correct power setting as airspeed approaches the desired value. Making a power change beyond the value necessary to maintain the next airspeed is only necessary in the region of neutral command or reverse command. Jets operating at cruise speed and propeller airplanes at most speeds operate in the region of normal command, where changes in drag will accomplish the change in airspeed in a timely manner without overpowering or underpowering. We'll now repeat these airspeed transitions in the flight deck view. Power is now being increased, and as the airspeed is increased, we see the pitch attitude decreasing, maintaining a constant altitude. And slightly before our target airspeed of 340 knots, we will reduce the power to the value necessary to maintain the airspeed constant. Next, we will do the airspeed reduction. First will be a power reduction. And as the airspeed decreases, we must accomplish an increase in pitch attitude. Note, while this coordination is taking place, the altitude remains constant. Slightly before reaching our target airspeed of 300 knots, we will set the power setting necessary to maintain it.